So greetings. So welcome to this course on vehicle dynamics. Uh, this course identifier is ED5220, and this course is one of the core courses of your program. So I am C.S. Shankaram. I will be teaching this course to you this semester. We will go through what we will learn in this particular course before we start off with the introductory concepts in today's course. Okay. So if you look at the title of this course, right, it has two words, uh, vehicle and then dynamics, right? So I'm sure all of us understand these two words, and we have a sense of what these words and the term vehicle dynamics is about, right? So we are essentially going to study about the dynamic response of road vehicles in this particular course, and I'm going to narrow down the scope of our study as we uh, start our discussions. Okay. So just before we go into the technical part of this course, just to set some course policies. So what we will have is that, like, we will have lectures on Monday, Tuesday, and Wednesday. Okay, every week, unless otherwise informed, or if there is a what to say holiday, right, declared on that day. Otherwise, we will essentially meet from 5 p.m. to 5:50 p.m. On all these 3 days every week. Okay, like through the course of the semester, as far as this particular course is concerned. And the Google Meet link for this particular course will always be the same. I have already shared an invite to you. So please use the same Google Meet link for the entire semester as far as this course is concerned. How will we essentially evaluate this course as far as the grading policy of this course is concerned? It will have three broad components. So the first one it will be assignments. So that will constitute 40% of your grade. So what do assignments entail? These may be homeworks, which I will be giving you, projects which I may give you towards the end, later part of the semester, later part of the course, and so on, right? So I will be giving you homework as and when we proceed with our discussions. Okay, so these assignments will constitute 40% of your final grade. So 30% of the evaluation will be done via a midterm exam. I will make an announcement regarding the midterm exam as we go along, and then like also clarify the what is the syllabus, so the type of exam that we will be having. So we will essentially have this midterm exam. Like once we complete maybe the first of 5-6 weeks of this course. Okay. So, and then like there will be a final exam, so which will constitute the remaining 30% of this course. That will be complete. That will be held once we complete our course. Okay, and the final exam will be comprehensive, right? So that's and some related notes associated with this course. As I told you, I'll be posting all the information the Google Classroom web page. However, what I will suggest is that, like, I will also alert you or direct you to two NPTEL massive online courses that I teach. One is on control systems, and another is on fundamentals of automotive systems. And these are also videos that are available online in YouTube, and then like you can watch them, right? So for getting to know some background material in case if you need them. Okay, so I will point it out as we go along, right? So there is one set of lectures, 36 hours on control systems. Okay, another set of lectures on what is called fundamentals of automotive systems. Okay, so where I talk about the basics of various automotive systems like the powertrain and the chassis systems, brakes, steering, suspension, tires, and also a little bit about EV powertrains. Okay, so you could watch those videos online. So that's something which I will essentially I would give you the links for these videos through the Google Classroom. Okay, so and as I mentioned, all the announcements will be posted through the Google Classroom page that I already set up. Okay, yeah, all right. So what are we going to study in this particular course? Okay, so once again, as I mentioned, you can please feel free to stop me whenever you have a question. You can essentially interject and ask me this question. Okay, ask me your question. Okay. So as far as this particular course is concerned, what are we essentially going to what are we going to learn? Okay. So we are essentially going to look at the dynamic response of four-wheel single unit road vehicles. Okay. So that is going to be the focus of our course. Okay, so this will include cars, SUVs, usual trucks or lorries and buses, two-axle buses, and so on. Right. So this is going to be the scope of this particular course. Okay, and when I talk about dynamics here, so we are essentially talking about rigid body dynamics. Okay, so we are going to treat the vehicle as a rigid body, and we are essentially going to apply concepts from rigid body dynamics for our analysis. Okay, so that's what we are going to do in this particular course. Okay, so we will also consider the dynamics of various vehicular systems and their interactions. Okay, so that's something which we are going to look at. So, for example, the powertrain, like the brake system, the steering, the suspension, and so on, right? And how do they essentially respond to various stimuli or input? And then, how do they interact with each other to essentially determine the overall vehicle response? Okay, so that's something which we are going to learn in this particular course. Okay, and how are we going to do this? So what is our broad philosophy? We are going to visualize a vehicle as what I call, quote unquote, a dynamic system. So we will be looking at what a dynamic system is shortly. So we are going to visualize or consider the vehicle as a dynamic system, and we will study its response. Okay, so that's what we will be doing. Okay, as part of this particular course on vehicle dynamic systems. So shortly, I will explain to you what a system is, what a dynamic system is, and so on. Okay, so we will look at them shortly. All right. So what I am going to do as part of this particular course is the following. I'm going to broadly divide it into 5 modules. Okay. And I'll be discussing each one of the 5 modules. So the first module is to discuss related concepts of dynamic systems. So I will be summarizing the main concepts, but then for a broader discussion, please watch the videos on control systems. Okay, so essentially you can access the videos for the NPTEL videos on control systems, and then you can learn more extensive theory on this. Okay, so but I am going to teach you only what is necessary, right? So if you're interested, you should watch these videos. Okay, so at least the relevant videos. Okay, not the entire lecture, but at least the relevant lectures you should watch. Okay. The second one, which I will also be recapping, will be concepts from rigid body dynamics. Okay, so I will be teaching you related concepts that we require from the theory of rigid body dynamics, Then we will start applying it to road vehicle dynamics. We will be looking at three broad aspects of road vehicle dynamics. The first one is longitudinal dynamics. Okay, so where we are going to look at first, in no particular order. So we will essentially look at acceleration or drive dynamics. Okay, where we are going to look at the powertrain response. Okay, so how the powertrain affects the vehicle's response. Okay, so that's going to be uh, looking at the subject of drive or traction dynamics. Okay, so this is related to the powertrain. And second, we are going to look at braking. Okay, so this becomes also like pretty important, and this will be useful when we look at active safety systems, ABS, and then like your stability control systems and so on. Right, so we will be looking at braking dynamics, okay, as we go along. Okay, and then we will be looking at lateral dynamics. In lateral dynamics, we are essentially going to look at essentially cornering, right? So what happens when we steer the vehicle? So lateral dynamics is also termed as cornering dynamics. So what is cornering? Cornering is a process of steering the vehicle, right? So that like we follow a desired heading. Okay, so this has to do with the response of the vehicle when we steer. Okay, so that's what we are going to. So what we will do is that like we look at the system response and also how it affects the overall vehicle response. Okay, so that's something which we are going to learn in this particular course. Okay, and the final module which we will learn would be on vertical dynamics. So where we look at suspension response. Okay, so we are essentially going to look at ride and roll, right, your pitch and roll. Okay, so that's what we are going to look at. Okay, so when we look at lateral dynamics, we are essentially going to look at steering yaw dynamics, right? So we can also call it as yaw dynamics, right? So when we look at vertical dynamics, we are going to look at suspension. We look at models that will help us analyze ride, pitch, and roll motions. Okay, like some of the vehicle. So that's something which we will be doing as part of this particular course. Okay, so this course consequently can be broadly divided into these five modules, and then like we will go through each module one by one. Okay, so that's what we are going to do. All right. Okay. So before I go into the first module, any questions on the overall course policy and what we are going to learn in this particular course?
Sir, the question from my side is about the midterm as well as the final exams. Will it be kind of a closed book or an open book exam?
Okay, so let us discuss it when we get there. Okay, so I would typically recommend a closed book exam for multiple reasons. Okay, but we can certainly discuss it when we get closer to the exam. Okay, yeah.
Sure, sir. Thanks.
Yeah, which one does your batch prefer?
Yeah, actually, in the past couple of semesters, we had one subject with closed book and another one with the open book. I just thought if how about this some are we having the same way or just wanted to confirm.
So typically, what I have been doing is it like I have been conducting closed book exams, okay, but I allow the participants to essentially have sort of like a one-page formula sheet, okay, just in case if it helps you, okay. But we will discuss the policy and modality when we come closer to the exam. Okay, so I'm keeping
Sure,
it
sir.
pending and open currently. We will discuss it. See, let's go through the course so that you will also get a flavor of what we are going to learn, how we are going to learn. Then you can also take a well-informed decision, right, as to which modality will be suitable for you.
Sure, sir. Thanks.
Any other
Uh,
questions?
Sir, regarding longitudinal dynamics, are we touching anything like related to tire or something, rubber
Ah,
or
so in what to say, both longitudinal and lateral dynamics, of course, I have to introduce some notions of modeling the tire rod interface tractive forces, right? So we'll be doing that. All right.
okay,
So we are
yeah,
not going to study tire mechanics per se, but we are
okay,
going to study to the extent such that we have to learn how the forces are characterized at the tire rod interface, right? For both longitudinal along the longitudinal direction and the
sure, sir. Thank you.
of course, because the tire road interface is extremely critical, right, in road vehicles, because all the forces and moments are transferred through the tire road interface. So we will be looking at it from the perspective of what is required for vehicle dynamics. Okay.
Oh, okay, sir.
Sir,
Sir, one more question.
Please go ahead.
Yeah, Ratish.
yeah,
Yeah,
sir, just
sir.
wanted to check. Yeah, Omkar, proceed, please proceed.
Yeah, sorry. Sir, will we be needing any software like MATLAB or Simulink so that we can arrange it?
Not what to say, mandatory, but it would help if you have it. Okay. Yeah.
Okay.
Right. So once again, we will go through the course. Most of the assignments are going to, I want you to work by hand, scan and upload. Okay. That's how it's going to be. But however, if we are doing some projects where you need to do some simulations, you may need access to MATLAB Simulink. Even you can get the, what to say, even the online version should be fine. Okay. Yeah.
Yes.
Sir, is control system is a part of this course or it will be a separate one?
So control of automotive systems is a follow-up course, okay,
Okay.
that will build on this course, right? So this course will teach the fundamentals of vehicle dynamics and which will be subsequently used to design controls.
Okay, sir.
So that is a course which I offer as an elective as part of the web-enabled MTech. Okay, so that will come subsequently.
Okay, sir. Thanks.
Any other questions? All right. So the concepts of dynamic systems and what we are going to learn through vehicle dynamics will form the foundations for automotive control. Okay, which we will look at later. Right. So we will anyway learn it as a separate course as we proceed in your program. So now let us look at dynamic systems. So once again, like there are two words, right? So the word dynamic and then the word systems, right? So what do we understand by that? So in the context of this topic, when we talk about something being dynamic and then like we use the adjective dynamic, so what we are essentially conveying is that things change with time. All right. So the quantities or variables associated with the system, right, or the process, they change with time. And time t is the independent variable. Okay. So and all other variables depend on time. So, for example, let's say we take the motion of a car, right? So its position, its speed, its acceleration, right? So are all functions of time. Okay, so we are going to use the word dynamic in that sense. Okay, so then one may also ask, okay, what is meant by system? Okay, because we have the title of this module being dynamic system, right? So what do we understand by a system? Okay, so different, what to say, in different contexts, the same word can have different meaning, right? So what is your understanding or what strikes you first when you listen to the word system?
The combination of certain components which will give me a desired output.
Okay, combination of certain components to give a design. Okay, fine. Any other definitions? So the same word can mean different things to different people, right? So I think one of you have been working on HVAC systems where thermodynamics plays a very important role, right? Heat transfer plays a very important role. So I'm sure you would have learned what was a system there, right? So essentially, as the what is this? Essentially the space, right, where we are essentially looking at the thermodynamic process that's happening, or the domain in space where the thermodynamic process is happening, right? So that we visualize as a system. If we look at fluid mechanics, the same word system will have a different meaning, right? So we'll be looking at a set of fluid particles that we are interested in studying and characterizing. All right. So you can see that immediately the word system can have different meanings, like depending on the field of study, like and how we are essentially going to visualize it, right? So as far as our course is concerned, and this broad domain of what is called dynamical systems theory. Okay, so whatever I'm going to teach essentially falls under the broad domain of what is called as dynamical systems theory. Okay, so as far as this particular domain is concerned, when we talk about what is called as a system, so we are essentially talking about an entity to which we provide an input, okay, and we get an output from it. Okay, so that's how we will be visualizing a system as far as our course is concerned. Okay, and this topic of dynamic systems is concerned. So let me uh, write down very carefully what is our visualization. So we provide an input to the system, and we get an output from the system. Okay, so that will be our uh, notion of a system. Okay, so for example, like I'm sure we can think of various examples. Let us say, we take a car for example, right? Let's say I press the throttle. So my in response to that, my car is going to accelerate and go. It is going to go to some speed. So I can always say the throttle displacement is my input, and the speed of the car is the output, right? So in general, we will denote the input by the symbol u, and we will essentially write it as u of t to indicate that the input is a function of time. We will denote the output by the symbol y, and then we will write y of t to denote that it's a function of time. Okay, and in general, we will call the system or represent the system as a mapping S, such that we write y of t to be equal to some S of u of t. So suppose, let's say we conduct a lot of experiments, right? And then like we essentially get a mapping between the throttle input and the speed of the vehicle, right? Under certain operating conditions, I can essentially get a relationship between them, right? That is this mapping, yes. Okay, so that's how we mathematically write our understanding of the system. So as far as this essentially course is concerned, we are going to look at a system as an entity to which we provide an input and we get an output. That's it. Okay. So, for example, let us say like we press the brake pedal, right? So we are going to get some deceleration, right? So the deceleration of the vehicle can be an output, right? So we turn the steering wheel. The steering input is our system input, and then the change in the orientation of the vehicle or the heading of the vehicle is the output. Correct. So like this, like we can essentially have different visualizations, right, related to our field of study as far as the system is concerned. And as I mentioned, the word dynamic essentially implies that all variables associated with the system are functions of time. Okay, so that's why we have the input u and y being functions of time. Okay, so I hope it is clear what is the notion of a system. So depending on the number of inputs and outputs, we can have what are called single input, single output systems and multi-input, multi-output systems. So these are abbreviated as SISO and MIMO. SISO means a single input, single output. Okay, so I gave you a very simple set of examples where it appeared that there was only one input, right? But in real life, we may have more than one input, right? So even in the case of, let's say, acceleration response, like I may be giving the throttle, right? And then I may also be giving a gear input, right? So there may be two inputs which the driver may be controlled. Okay, so consequently, one is going to have multi inputs, right? Multiple inputs coming into play. I may be also giving a clutch input, right? So that is also another input which I need to consider, right? So sorry, some error here. So on the other hand, a MIMO system or a multiple input, multiple output system will have more than one input and more than one output. Okay, so that's what is called as a MIMO system. So that is the abbreviation for multiple input, multiple output systems. Okay, so these are what are called MIMO systems. Okay, so we will essentially be studying about CISO systems first, and then we see what class of systems vehicle systems fall under, right? So when we essentially start looking at vehicle dynamics, okay. Of course, but if we essentially are going to look at dynamic systems, we need to analyze them and study them. First, we need to get the mapping, yes, right, between the input and output. See, for example, let us say, someone here wants to develop a powertrain control, right? So then one needs to figure out, hey, what will be the relationship between the input, which may be throttle, gear, clutch input, and let's say the torque output that comes from the powertrain, right? So let's say someone wants to develop a braking controller, right? So then one needs to ask, what is the relationship between the brake input, brake pedal displacement, and let's say the braking force or braking torque that I get, and so on. Okay. So consequently, the first task at hand in this line of study is the following, right? So we need to obtain the mathematical mapping or the mathematical relationship, right, between the input and output. Okay, so mathematical mapping / relationship between u of t and y of t. Okay, so this is what is called as a mathematical model of a system. Okay, so once again, the word model can mean different connotations to different people depending on the field of study. So when we talk about modeling in our context, in this course, we are essentially going to talk about a mathematical model where we are going to characterize the system using a set of mathematical equations. Okay, so that is the first task at hand. And we will be spending most of our time in this course dealing with mathematical modeling. Okay, so that's what we are going to do, right? So we are going to, in this particular course, we are going to mathematically model the vehicle dynamic response. Okay, so that's what we will be doing. And now, in fact, we will see that we will be basically dealing with three broad problems. Okay, so please remember our notion of system. A system is an entity to which you give an input and we get an output, right? So essentially, we are going to look at three broad problems in this domain. And then we will also identify which problems we are going to consider in this course, right? So the first problem is that, let's say, given u of t, the input, and y of t, right? Find the mapping S. Okay, so this is a very important problem, right? So because let's say, even let's say if I want to essentially look at the development of a steering controller, right, for an autonomous vehicle application. So now, first I should understand how my vehicle will respond when a steering wheel input is given, right? So consequently, let us say I am given the vehicle information and also data on the steering response, in terms of steering wheel angle inputs and the corresponding, let's say, your acceleration, your rates, heading angle change, and so on, right? I first find the relationship between these variables, okay? So this problem, which is very, very important, which typically is the first step in this line of study, is what is called as a synthesis, okay? So in the synthesis problem, we are going to synthesize deals with the synthesis of mathematical models, okay, and which is what we are going to focus on for most of this course, okay. So when we look at vehicle systems, like, and we want to study the dynamics, we are going to synthesize mathematical models for various vehicle systems and the response, okay. That is the first step, the first problem that we do. Then the second problem is that, let us say we model the steering response, right? So tomorrow, let us say I change the road condition, right? So suppose it rains today, right? And then the roads have become wet. So the tire road traction characteristics have changed. Now, if I give the steering input, I want to predict how my vehicle's heading will change. So I am giving you an example of the second problem. That is, given the system and the mapping is, and the input to find the output y of t. Okay, so this follow-up problem one could do. Of course, to do this, we should have done the synthesis problem, right? Only then we can do this problem. And this problem is what is called as the analysis problem. Okay, so the analysis problem can be done once we complete the synthesis problem. And then, like, we essentially are looking at what will be the output of the system to any arbitrary input. Okay, so this is the problem of analysis of dynamic system response. Okay, so this is the second problem one could do. All right. So now, having discussed analysis, now let's we are building an autonomous car, right? So someone tells me, make the vehicle go along a specified desired path. So then I need to ensure that the vehicle's heading is appropriately regulated, and I have to figure out what should be the corresponding steering angle inputs that I should provide, so that the vehicle goes along the expected trajectory or path. Okay, so that is the third problem. So the third problem is the following: given the mapping is and y of t, the output y, okay, find u of t. Okay, so this is the third problem. Okay, so this is what is called as control problem. Okay, so what is the problem of control? So I want to essentially have a desired output. Okay, I know what the system is. The question is, can I find the input? And that is what we considered in the example which I stated, right? So if I wanted an autonomous steering system, right, I know what path or trajectory my vehicle should follow. Consequently, I need to find out what input I should give, right? So that's essentially deals with control, all right? So these first two problems, that of synthesis and analysis, are what we will learn in this particular course. So in this course on vehicle dynamics, like, we will be dealing with this synthesis problem, where we synthesize mathematical models, and then the analysis problem, where we are going to analyze the system response based on the mathematical models and gain some insights into their characteristics. Let it be a longitudinal response, there is acceleration or braking response or steering response or suspension response. Okay, so once we learn it in this particular course, as I mentioned, subsequently we will learn a course on control of automotive systems, where we will do the third part. Okay, we will equip ourselves with the tools which will help us in figuring out what should be the input that I should provide to get a desired output. And this is a challenging thing to do, why? Because, see, philosophically, let's say, like, we have y of t to be s of u of t, right? So that is our notion of a system, right? At least mathematical notion of a system. Now, when I'm talking about control, I need to find U, right? So what happens is that I need to invert this mapping, yes, right? So now given S, Y of t, I need to find U of t, okay, knowing the system. So philosophically, what I'm doing is that I need to solve this inverse problem, right? Wherein I need to find now y u by as S inverse y of u, okay? And such problems are difficult to solve, okay? So it's not as easy, I'm just presenting a overall macroscopic, very simplified view of things, just to show that, if I invert, I will get the answer. But the real problem is not that simple. So to first get the mapping, yes, relating y and u itself is will require a lot of domain knowledge, which we are going to learn in this course, right? Then solving the control problem is requires more tools, which we will learn in the subsequent course. Okay, so that's how this course is structured. Okay, so obviously, we are going to use a lot of mathematical tools, in this particular course. And if you ask me, what mathematical tools, concepts are required, I would be revising whatever is necessary as we go along. Okay, so we will have recap of all these mathematical tools, and I'm sure all of us would have studied them in a basic undergraduate course in mathematics during our bachelor's degree, right? But I will obviously revise them, okay, as we go along. So we will observe that most of the vehicle dynamic models are going to be expressed in the form of ordinary differential equations. Okay, so abbreviated as ODEs. So most vehicle dynamic models will take the form of ODEs. So we need to know what are the characteristics of ODEs, how do we solve ordinary differential equations, and so on. Okay, we need to know a little bit about complex algebra, complex variables, and so on. Okay, so we will see that this is going to be useful, and we need to know a little bit about Laplace transform, so that we can do some analysis of the mathematical models to gain some insight. Okay, and of course we need to know a little bit from the theory of polynomials to do some analysis. Okay, so these are some mathematical tools that will be required as part of this course. Okay, so but as I mentioned, we will recap the relevant important concepts as we go along, and I will do examples in class. I will also give you homework problems to solve, okay, so that you can do them and gain confidence as we go along. All right. Okay. So this is what we will be doing in this particular course. So I hope in this lecture you have got a broad idea of what we will be doing and what our approach will be, and what we are going to learn as far as vehicle dynamics is concerned. So from the next class onwards, we will dive into the details of dynamic systems, and then we will learn the related concepts and tools before moving on to rigid body dynamics and its application to vehicle dynamics. So let me stop here for today's lecture. Are there any questions based on the content that we discussed?
Sir, any reference books or something you're going to refer, or sorry, suggest?
Okay. Sure. Okay. What I will do is that I will post the list of references in the Google Classroom page. Okay. Yeah.
Okay. Okay.
Yeah.
Sir, if you can share the syllabus also, it will be helpful, sir.
Sure. Okay. What I will do is that I'll share all that information in the web page. Okay. Yeah.
Sure, sir. Thanks.
Any other questions before I close today's session? Okay, so if there are no further questions, let me stop recording.